Good afternoon, everyone. I hope you all are well. So we will continue with our discussion with science and technology. And as I said in the last class that first half of the class will be on space science and technology, and then we'll go into nuclear science and technology. We'll start with a new topic in the classroom. Now, before I start with the respective topics there, let us see a few of the questions which you have in your self-test assignment in the login page, right? After every class, in every subject you get in Vision IAS login platform, questions are there, right? So you have a 7 objective type questions. We'll discuss that one. Let's say here first question. In your self-test, the first question, which of the following are not correct about the launch vehicle technology of India, right? India has evolved a 3-stage development program. Second, India's first satellite launch vehicle was the PSLV. Third statement, PSLV is the first launch vehicle in India which uses liquid propellant only. And the fourth statement is the first stage of GSLV works on cryogenic engines. All of these statements are not correct. All these statements are not correct. Last class I have discussed from ISRO perspective that we have 4 types of rockets or launch vehicles which we have developed in the past. First one was SLV-3, 1980. Then followed with the ASLV, 1987. Then 1994, PSLV. And 2001, GSLV. So statement number 1 is wrong. Then India's first satellite launch vehicle was PSLV. That is wrong. India's first successful developed experimental launch vehicle was satellite launch vehicle 3rd, SLV-3. Right? Now third statement, PSLV is the first launch vehicle in India which uses liquid propellant only. The statement says liquid propellant only. That is again wrong. PSLV is the first rocket in India which use solid with liquid alternatively. And ISRO has developed the liquid engine. There is a center of ISRO called LPSC, Liquid Propulsion System Center, Mahendragiri in Tamil Nadu has developed Vikas engine. What is the name of the liquid engine? It is called Vikas engine. So PSLV use both solid and liquid. Solid followed by liquid, then again solid followed by liquid. So solid, liquid, solid, liquid. It is a 4-stage rocket. Statement number 3 is also wrong. Now statement number 4, first stage of GSLV works on cryogenic engine. Again wrong. Cryogenic engine comes in the 3rd stage of GSLV. GSLV has first stage solid, second stage liquid, and the upper 3rd stage, that is a cryogenic engine. So all these 4 statements, 1, 2, 3, 4 are incorrect or not correct. So question number 1, the answer is C, 1, 2, 3, 4, because question is asked that which of these following statements are not correct. So all the statements are not correct. Answer will be 1, 2, 3, 4, C as an answer. Now question number 2, Mars orbiter mission. This question came in the examination, right? This was asked in 2016 prelims exam. Let us see what the question was asked in UPSC exam. Consider the following statements about Mangalyaan launched by ISRO. Statement number 1, it is also called the Mars orbiter mission. Correct. MOM, Mars orbiter mission, that is correct. Second statement, it made India the second country to have a spacecraft orbit Mars after the USA. That is wrong. That is wrong. USA, NASA, Russia has also tried with a mission to Mars planet. European Space Agency has also tried. Japan has also tried. JAXA has also tried. So India is not the second country, right? The statement number 2 is wrong. Now the third statement, it made India the only country to be successful in making its spacecraft orbit Mars in its very first attempt. This statement is correct. India, among such nations which tried with Mars orbiter mission, there India did in one go. India successfully inserted the Mangalyaan into the Mars orbit in first attempt. That's the credit of ISRO goes into that. So this question which came in the UPSC exam, right, 1 and 3 are correct. So answer will be C, 1 and 3 are correct. Right? Is the question difficult? This question, is it difficult? It's not difficult, right? UPSC questions are not difficult. If you know the main part, if you know the main aspect, if you know the facts, if you know the concepts very well, it becomes very easy to solve questions, right? So the answer is 1 and 3 are correct. So C has an answer there, right? Now coming to question number 3. Again on launch vehicle technology. Question number 3. Consider the following statements regarding launch vehicle technology of India. Statement number 1. India's first satellite launch vehicle was the PSLV. Wrong. India's first launch vehicle was SLV, satellite launch vehicle. Second one. PSLV is the first launch vehicle in India which uses liquid propellant only. Wrong. I have just explained right now. It uses solid with liquid. So second is wrong. Third one. The first stage of GSLV works on cryogenic engine. Again wrong. The third stage works on the cryogenic engine. So again here, all the statements 1, 2, 3 all are wrong. Question is not correct. So answer will be D. Question 3 answer is D. Now question number 4. Question 4 was asked in UPSC exam in 2011. Question number 4 in your self-test question was asked in the UPSC prelims exam in the year 2011. And we have covered this concept of orbit. So what is the question here? Question number 4. Satellites used for telecommunication relay are kept in a geostationary orbit. A satellite is said to be in such an orbit when, number 1, the orbit is geosynchronous. Number 2, the orbit is circular. Number 3, the orbit lies in the plane of the Earth's equator. And fourth, the orbit is at an altitude of 22,222 kilometers. Statement number 1 is correct. It is geosynchronous, right? What is geosynchronous means? When a satellite revolves around the Earth with respect to Earth's rotation. That is called geosynchronous. Circular orbit, right? Geostationary is a special kind of geosynchronous orbit. The difference is that the orbit is circular and the orbit is located at approximately at a distance of 35,784 kilometers. So the third statement, that the plane of the Earth's equator, is also correct. But the fourth statement is wrong. What is the fourth statement says here in the question? The question says that the orbit is at an altitude of 22,222 kilometers. That is wrong. The orbit lies at an altitude of 35,784 kilometers, or you can say 22,222 miles. If you convert into mile, kilometer into miles, then it will be 22,222 miles will be there. So statement number 4 is a factual mistake given in the statement number 4. So the answer of this question is 1, 2 and 3. So question number 4 answer is A, 1, 2, 3 and 4, right? Answer will be A here. Now question number 5 about cryogenic engine. It uses liquid hydrogen as a fuel and liquid oxygen as oxidizer, correct? The fuel is stored at room temperature. That is wrong. The fuel is stored at a supercritical low temperature, very, very low temperature. Now third one, it reduces the efficiency of the engine despite being a clean fuel. Wrong. It increases the efficiency of the engine. So the answer here is, which is correct option? A is the answer. Answer will be 1 only. A as an answer there. Now question number 6. With reference to scramjet engines, consider the following statements. Number 1, the scramjet engine designed by ISRO uses hydrogen as fuel and the oxygen from the atmosphere air as an oxidizer. Correct. I have already discussed this in the classroom that it is called air breathing propulsion system. Number 2, statement number 2, this system would help in reducing the lift-off mass of the vehicle. Correct. Because there will be no need of oxidizer. So the question number 6, both the statements are correct. Answer will be both 1 and 2. Answer is C as an answer. Question 6 answer is C as an answer. Now question number 7, the last question. Which of the following are correct regarding the RLVs, reusable launch vehicles? We have discussed that also in the classroom. Now number 1, India was the second nation to successfully conduct the flight demonstration of a scaled down version of a winged body reusable launch vehicle. Wrong. India is not the second country. USA, Russia, China. India is the fourth country. Right? What is the mistake there in the statement number 1? The second nation, that is wrong. India is the fourth nation of the world to develop such kind of RLB technology there. So the statement number 1 is wrong. Now statement number 2, RLB TD technology demonstrator was successfully flight tested from Satish Dhawan Space Center, Sriharikota High Altitude Range, SHAR, Sriharikota, validating the critical technologies such as autonomous navigation, guidance and control, reusable thermal protection system and re-entry mission management. Correct. Statement number 2 is correct. Statement number 1 is wrong. Statement number 2 is correct. So the answer will be here B. B for Bombay, 2 only. Question number 7, answer is B, 2 only. Right? So there is a question by Mr. Rohit Nandan Dikshit. Polar satellites and sun synchronized satellites are the same. The first part of the question. Second, he is asking that PSLV only launches sun synchronous orb satellite. Wrong. PSLV is the most reliable workhorse of ISRO. We are going to discuss that. Last class I told you that I will be discussing PSLV and GSLV in the classroom. PSLV can also launch communication satellite. And I have already discussed a very important concept in the classroom. What is that concept called as? If you remember, I have discussed the concept in the classroom. I have discussed the concept of transfer orbit. What orbit? Transfer orbit. Geosynchronous transfer orbit. PSLV can launch a communication satellite of less than 1500 kilogram into geosynchronous transfer orbit. What is geosynchronous transfer orbit? GTO is a highly elliptical orbit with a perigee somewhere around 200-250 kilometers, apogee around 36,000 kilometers, right? The second part of the question, what you are asking, Mr. Nandan Dikshit, is PSLV only launches sun synchronous. Wrong. Now your first part of the question, are the polar satellites and sun synchronous satellites are the same? See, what is polar satellite? Polar satellite is that satellite which goes in a polar orbit. What is polar orbit? Polar orbit is an orbit where satellite goes from north to south. It moves from north to south direction. What is sun synchronous orbit? Sun synchronous orbit is a polar orbit. Whenever you read in the launch, you will come across SSPO, sun synchronized polar orbit. Right? Sun synchronized polar orbit. But can sun synchronized orbit be other than polar orbit? This is what Nandan is asking. Can there be a case where a sun synchronous orbit is not a completely a polar orbit? Is it possible to have that? Or is it that all the sun synchronous orbit which follows with respect to sun's movement across a particular direction there are all polar orbit? They are basically, see, sun synchronous orbit can be other than polar orbit, right? But when we talk about polar orbit, we are using SSPO. So let me draw this diagram here. So when you talk about Earth here, right? So this is the polar orbit, where a satellite, remote sensing satellite, where we use remote sensing satellite. For Earth observation, let's say for example, India has developed Cartosat, right? Cartosat, ResourceSat, these all are the remote sensing satellites of India, right? So when a satellite goes into this one, it follows a kind of a polar orbit. This is the SSPO. Sun synchronous polar orbit. This is the sun synchronized. Polar orbit. It is also called a dawn to dusk, morning to evening kind of satellite. So the satellite moves in this kind of orbit. It follows this kind of trajectory, right? So it goes to a particular part of the landscape, right? And it again comes back. By that time it rotates. So it keeps on doing the observation, getting the data there, right? PSLV, see PSLV is that rocket which built in India primarily It was meant for remote sensing satellite, but in the beginning, I'm making a very, very important statement. PSLV is the most reliable workhorse of ISRO. We have used PSLV to launch INSAT class of satellite. What is INSAT class of satellites? INSAT class of satellites are communication satellites. Right? So what is first? So Nandan question, your first part that are the polar sun synchronous orbit, right? Polar orbit will be sun synchronous. But can there be sun synchronous orbit other than polar? Yes, it is also possible. It may be somewhere inclined, but maybe following the sun's direction. What is sun synchronous? It can trace. It can trace, right? It is based on the revolution aspect of the Earth. Sun synchronous orbit is based on looking into the Earth's revolution around the sun, right? So generally it is a kind of orbit which goes to the polar orbit there. And second question, that what about PSLV communication satellite? Yes, PSLV can launch communication satellite, but with a less pale weight. Weight of the class of the satellite should not be 2000 or more than 2000 kilogram. If it is a heavier communication satellite, we will prefer to use GSLV rather than PSLV. PSLV we have used in the Mangalyaan mission. Even for Mangalyaan mission, we used PSLV extra large version, XL version, for launching the Mangalyaan into the orbit. PSLV C-25 was used, right? So PSLV is a very important rocket of India. And in the beginning, we have used PSLV to launch INSAT class of satellite, which are the communication satellite. Nandan's question is very, very important question. What Nandan has asked the question is a very, very important question, right? Nandan's question is very, very important question, what he has raised there. All right. So is it clear here, what I mentioned here? Now let's look at here. I'll now come to the PSLV and GSLV and those part of it. So if you take the differences here, polar satellite launch vehicle and geosynchronous satellite launch vehicle, I'll give you in a tabular form here. Last class in the handout, I have already discussed that, right? Last class I have already given you the part of that. So I have already discussed in the classroom there. So you don't have to worry about that part. Now let's look at here. Polar satellite launch vehicle. What is first point here? First point is that this rocket was developed with the purpose of launching remote sensing satellite into the sun synchronous polar orbit, but it can also launch communication satellite of weight less than around 16 kilogram, 1600 kilogram, not very heavy one, into GTO, what is called as a geosynchronous transfer orbit. And you will see here, if I just take it to here, now just look at here. Whenever you have to look into data, right, whenever you have to look into data, you should always go to the ISRO site. You should always refer to ISRO site. Now look at here. This is what you have, the PSL, all the launchers here, right? I'm showing you the image of the launchers. Right from the beginning, SLV3, ASLV, PSLV, GSLV, we have in GSLV Mark II, GSLV Mk2, and then we have a GSLV Mark III. Now if you look at here, PSLV extra large, there is a version of PSLV called PSLV extra large, which we have used for Mangalyaan mission also there, Chandrayaan 1 Mangalyaan. Now if you see here, for PSLV extra large, what is specification here? Height is 44 meters, lift-off weight is 320 tons, propulsion solid and liquid, payload mass 1860 kilogram, orbit 475 kilometer, sun synchronous polar orbit, right? And 1300 kilogram in geosynchronous transfer orbit, right? It's very clearly given. Now if you look at the GSLV Mark III, this we have a GSLV Mark III, Mark II, and then we have a Mark III. Right, GSLV Mk1, Mk2, Mk3. Now if you see the Mark II and Mark III. Mark II, if you see here, 2200 kilogram into GTO, geosynchronous transfer orbit. Whereas the Mark III, that can take up to 4000 kilogram into geosynchronous transfer orbit. that is the Mark 3 can take into that, right? So what you find here is that PSLV can also launch communication satellite, but not very heavier one, right? Not very heavier one. We can see here, and when you go to the here on the right hand side, if you just go to the right hand side here, PSLV part, right? So here you have a specification part of it. PSLV is the third generation launch vehicle of India. It is the first launch vehicle to be equipped with liquid stages. Launched in first successful launch was in October 1994, and it has also launched Chandrayaan 1 in 2008, and Mangalyaan was launched in 2013, right, using PSLV. And you can see here the specification has been given. In the beginning, if you find here, the first stage of the PSLV, that is strapped with 6 solid motors. You can see the small rockets are there. 6 step-on motors are fitted into the first stage of the rocket. Now 6 solid rocket step-on motors is used there to augment the thrust provided by the first stage of the PSLV. And that is in the standard version, PSLV G, and extra large version. But the core alone, which has the core alone version, doesn't have any step-on motors. Then the first stage, you have solid 139 solid rocket with 6 step-on boosters there, and it uses HTPB as the solid fuel. Then second stage, you have a liquid Vikas engine, UDMH and N24O4 are the fuel. Third stage is the solid STPB, and then last stage, the fourth stage, you have the here liquid engine. This is how the PSLV looks into that, right? PSLV comes into that. Now, if you see the GSLV, if I just go to you the GSLV part of it, the GSLV here, Mark II, and from January 2014, the vehicle has achieved 4 consecutive successes there. Now, GSLV Mark II, if you look at the Mark II in the first stage, you can see there 4 strap-on rockets are used, strap-on motors are there. The 4 liquid strap-on motors are used in GSLV Mark II, right, which are based on Vikas engine derivatives. Then come the first stage, solid, second stage of GSLV Mark II, liquid, and the last upper stage, cryogenic engine, CE 7.5, right? Now, if you see here, Mark III, if you just go through the Mark III. Now, Mark III is a very different type of rocket. Mark III, if you look at, Mark III, you will find here that it is a rocket which has a technical specification. If you look at here, it has a first core. What you see here, this is the core one at the center. At the core, you have a liquid one, which has flanked sidewise 2 heavy solid boosters. It uses 2 heavy solid boosters sidewise, and then you have a core liquid one, which is here. You have a liquid one, but 2 solid boosters are there. Liquid one is L110, solid one is S200, and the last what you find, this one is the cryogenic engine, which is a C25, that is a cryogenic engine. And GSLV Mark III can launch 4,000 kilogram satellite into geosynchronous transfer orbit, right? And 8,000 kilogram into polar orbit at 600 kilometer orbit there. C25, C20, that is a part of cryogenic engine, right? So this is where, when you read the information from ISRO site. So you have to always remember that whenever you are looking for authentic data, correct information, you have to go to the ISRO website and try to see the important data there. But I'll give you in tabular form here. So what is PSLV? So it is primarily, now you can write this in your note copy, primarily meant to launch Earth observation, remote sensing satellite, into sun synchronous polar orbit, but it can also launch up to 1200 kilogram communication satellite. Initially, the InSats were launched, InSat series satellites were launched by using PSLV only. Communication satellites into geosynchronous transfer orbit, GTO. Whereas the GSLV, what is it developed with? It has been developed meant to launch heavier communication satellite. Heavier communication satellites, right? From how much there? 2 ton to 4 tons. Like GSLV Mark 3 can launch up to 4 tons. Meant to launch heavier communication satellites 2 ton to 4 ton into geosynchronous transfer orbit, GTO. Right? Now what is the second difference? Second difference is that PSLV is a 4-stage rocket. Is a 4-stage launch vehicle with first and third stage. With first and third stages using solid propellant or fuel, and second and fourth stages using liquid as a fuel. Using liquid fuel or propellant. What I've given in the table, the second point, that PSLV is a 4 stages launch vehicle. LV stands for launch vehicle, with first and third stages using solid fuel and second and fourth stages using liquid fuel. On the other hand, GSLV is 3 stages rocket or 3 stages launch vehicle, with first stage using solid fuel or solid propellant, second stage using liquid fuel or propellant, and the upper third stage there where we have indigenous cryogenic engine using now indigenously built cryogenic engine with liquefied hydrogen and oxygen. Right? Now what I'm coming here, there are three types of configuration. So PSLV, you have 3 versions are there, or variants you can say, or you can say configuration. Right? Which are the versions and the configuration of PSLV? 3 configuration. One is the core alone. The first one is the core alone. The first version is called core alone. Now core alone is represented by PSLV CA. That's the core alone. Now what we find in core alone? It doesn't use no strap-on motors are there. It doesn't use any kind of strap-on motors in the first stage to provide additional thrust. It is simply here the rocket you have a solid, liquid, solid and liquid. This is called core alone. Now the second version PSLV has got, that is called as a standard version. Now standard configuration is represented by PSLV G, that is called standard configuration. Now in standard configuration, and the third one is called extra large, XL. Now extra large version, which can take more heavier satellites there. Now extra large version and standard version, they use here, they use strap-on motors. Right? The use of strap-on motors in the first stage. Now what do you find here in this context here? It looks like you have a solid, then liquid, solid, and then again liquid. At the top you have a box where satellites are kept, and then it uses six step-on motors which is tapped on the first stage. I'm just drawing a rough diagram here. There are six step-on motors. Right? The six step-on motors which also work on the solid fuel. This gives the additional thrust. Right? So this is the standard and the XL version. Extra large version has more heavy, this solid one, which gives some more thrust there. Right? GSLV, if you look at GSLV also has got three configuration. GSLV also has got three versions or three configurations are there. The first one is called GSLV Mk1 Mark 1. Right? Now Mark 1, you can go up to 1600, 1800 kilogram satellite there, and up to 2 tons. Here, up to 2 ton. Up to 2000 kilogram satellite can be launched by GSLV Mark 1. Now what is GSLV Mark 1? It's just a very simple rocket where you have simply, with no step-on motors, it's simply here solid, liquid, cryogenic. But now we are not using this Mark 1. We are not using right now. Right? What we are using is the Mark 2, GSLV Mk2. Now Mark 2 we can go from up to 2500 kilogram. We can, like up 2500 kilograms class satellite, we can use the Mark 2 here. So here 2 ton to 3 tons. 2500 kilogram and all, we can use that. But what is difference here is that in the Mark 2 we use 4 step-on motors, or you can say boosters, in the first stage. What we find in the Mark 2 version is that in the Mark 2 version we have 4 in the first stage. You'll find there are 4 step-on motors which are strapped into the first stage of the rocket of GSLV Mk2. And here this rocket, these 4 step-on motors are there to provide additional thrust. And these are liquid based. It burns the liquid fuel. It's a derivative of Vikas engine. Here the engine which PSLV, Polar Satellite Launch Vehicle, this engine, the liquid engine, right? This is the liquid engine which is called Vikas engine. Right? Now if we see the Mark 3, the most heavier one, GSLV Mark 3, the most heavier one. So it can place up to 4 ton, like 3 ton to, we can go up to 4 ton. Not more than 4 tons. 4 ton, 1 ton equal 1000 kilogram. 1 ton is equal to 1000 kilogram. GSLV Mk3 can go up to 4000 kilogram of a heavier communication satellite into geosynchronous transfer orbit. In case India has got heavier than 4000 kilogram or heavier than 4 ton, then we have to rely on some other countries' rocket to launch our satellite there. Like most of time when our GSAT, multi-purpose satellite, is very heavy, more than 4000 kilogram, we take help of France. We take the help of France, that is the CNES, that is the French Space Agency, to launch the heavier communication satellite. And that is launched from Kourou. Where is Kourou? French Guiana. Where is French Guiana? That is in the Atlantic Ocean in the South America. Right, in the Venezuela, nearer to Venezuela, on the Atlantic Ocean, there is an island called Kourou, where French Guiana island is there. And there from France does the launch because of being near to 0 degree line, being near to the equator. So we take the help of France then, if we have a more than 4,000 kilogram there. Now if you look at the GSLV Mark III, how GSLV Mark III looks like? GSLV Mark III, you'll find, I'll just use the new marker here. It has two very heavy booster. It uses two heavy boosters which are flanked sidewise. You'll find this booster here, which are on the sidewise. Now this uses S200, solid fuel 200 tons, S200, right? Then you have this liquid engine. Here you have a liquid engine, L110. And then the last stage you have cryogenic engine C20 or C25 here. This is a cryogenic engine. Mark III is the heaviest rocket launch vehicle developed by India. So it has a two sidewise solid boosters which has S200, solid fuel 200 tons each capacity. That burns and separates. Then you have a liquid one, L110. And then after that third stage, that is a cryogenic engine. Cryogenic engine is there. For Chandrayaan mission, for Chandrayaan 2, to carry the orbiter with the Vikram lander and the Pragyan rover, we used GSLV Mk3 Mark III M1. For Gaganyaan mission, India's manned mission, we are again going to use GSLV Mark III, right? GSLV Mark III D1 and D2 has launched GSAT 19 and GSAT 29. They are heavier communication satellites, right? So this is what you have to remember from the point of view of the PSLV and GSLV there, right? The liquid engine is this one, what I mentioned, L. First is a solid, then you have liquid, solid, liquid. This Vikas engine, this is the liquid based engine. Vikas engine is a liquid based. So again here, you have a solid here, this is a solid one, then you have a liquid here, then you have a solid, and then you have a liquid. So first stage solid, second stage liquid, third stage solid, then again fourth stage liquid. SL. Right? That is the PSLV. Is it clear here? What I have explained here, the entire rocket, is it clear here? So please write these points there. But I think now UPSC will not ask the question. Why? Already UPSC has asked the question. 2018 exam, there was a question on difference between PSLV and GSLV. It has already been asked in the exam. But you should be aware of that, right? Is it clear? Any doubt you have with PSLV and GSLV? वो कैमरा आप फुल बोर्ड को कैप्चर कीजिए. एक स्टूडेंट का रिक्वेस्ट आ रहा है कि वो पूरा कैप्चर होने के लिए. नहीं, एक बार कैप्चर करके दिखा दीजिए इनको, इनकी तसल्ली के लिए दिखा दीजिए इनको. एक बार पूरा कैप्चर कर दीजिए, फिर उसको जूम कर दीजिए. Is it clear? Shivam Pathak, you have requested to capture full board, right? So एक बार बस एक बार करना है, पूरा हो गया, फिर उसके बाद जूम कर दीजिए आप. ये मार्कर चाहिए, ब्लैक पूरा खत्म हो गया, ब्लैक मार्कर बिल्कुल काम नहीं कर रहा. Any doubt with respect to PSLV, GSLV? I had given you all the points on the whiteboard. You have all the points given here, and very clearly these 3 points I have kept into that. But again, what I said is not very important now. Why? Already UPSC has asked the question. You should be aware of it, but not very important for that. GSLV Mark 3 is important for us because we have carried out Chandrayaan 2 mission. Chandrayaan 3 will also be, Mark 3 will be used that. Human space flight Gaganyaan will be also with the help of the Mark 3 to take a crew module and then bring the crew module, right? We will be launching the crew module using the GSLV Mark 3 only there, right? Is it clear here? Is it clear here? If you want to ask anything, you can ask me now, or else we'll move to the next topic. All right. There is one doubt from a student called Durgesh. Durgesh Singh has asked a question about Lagrange point and Aditya L1 mission. See, I have very clearly in the previous class, when I was discussing about Lagrangian points, all the 5 Lagrange points, I have very clearly stated in the classroom that Aditya L1. What is the name of the mission? Aditya L1. We don't say Aditya, something else. Whenever the mission is named, it is said Aditya L1 mission. See why I am making this statement, because Durgesh question, what Durgesh is asking the question about Lagrange point, I am bringing it here because you have to be very, very clear with the concept. ISRO has planned to take the Aditya spacecraft into Lagrange point 1, right? Durgesh is asking that is it Lagrange point 1 L1 or any other point is there? Is going to be any other point or Lagrange point 1? It is Lagrange point 1. But I have mentioned you one very important concept in the classroom, halo orbit. I don't know whether Durgesh, you were present in that classroom or not, or whether you have reviewed the class video, recorded video, right? Because I know that many of the students who are having double classes, so you attend afternoon class and then you disappear in the evening class, right? I know that this is where the students have. So I don't know about Durgesh whether he has attended that class where I discussed about L1 point, and I have very clearly mentioned, and I have opened the ISRO site also, ISRO site, and I said that 1.5 million kilometers there will be a halo orbit. There is something called halo orbit. What is halo orbit? It's a 3-dimensional orbit, right? It is not a point, it is a 3-dimensional orbit called as halo orbit, where we are going to place Aditya spacecraft. In the classroom, I have also mentioned that keeping the Aditya spacecraft into such a halo orbit around L1 point, right? Around L1 point, there is a halo orbit. Where there, if we place the Aditya mission, Aditya spacecraft, we have one major advantage that it will not be affected by the eclipse. There will not be any occultation. There will not be any occultation because of the eclipse, because Earth's moon is located 384,000 kilometers away from the Earth. What is the distance of the moon from the Earth? That is approximately 384,000 kilometers away from the Earth. whereas the Lagrange point, that particular point in the space, is located 15 lakh kilometers away from the Earth. So having a spacecraft at that particular L1 point, it means that there will not be any occultation because of the eclipse, lunar eclipse and all. But again, I said it is not a point. Point is a misnomer. What Durgesh is asking the question, point is a misnomer. It will be placed in a kind of a orbit called as a halo orbit. HALO, halo orbit. That will be around L1 point. Right? And that halo orbit will be in such a way that it will follow both the Earth, and with the Earth it will go around the Sun. It's a very complex kind of orbit called halo orbit, where it will not only in terms of the Earth, but also with respect to the Sun. So the Aditya in that halo orbit will keep on capturing the images, capturing data from the Sun and relaying it back to the Earth. That's where the halo orbit concept comes. Right? Durgesh, is it clear here? Because Durgesh is confused, right? Durgesh has the confusion regarding this L1 point. So first part of his question was that, is it L1 point or anything else? So what is that anything else? Halo orbit. So Durgesh, your first part of question is halo orbit. Will place in a halo orbit around that point. It's not exactly a point. You should not consider it as a point there. There will be an orbit, a three-dimensional orbit around that L1 area, where we are going to place Aditya spacecraft. Now, second part of Durgesh was that what advantage it has got by placing there. The advantage is that first of all, the occultation or effect of the eclipse can be minimized, and second thing is that it will go with the Earth. That halo orbit at L1, that will go with the Earth. So the Aditya spacecraft will continuously keep on looking at the Sun, collect all the data, solar tsunami, solar particles, right? Observing the corona of the Sun, getting all the data, and that data will be relayed back to the Earth. It will go to the ground station, right? But again, remember that halo orbit keeping a spacecraft is not an easy task. It's a very difficult and challenging task, and the satellite has to be controlled from the ground station. We have to always keep on correcting the path of a satellite in the halo orbit. That means Aditya spacecraft. Continuously we have to monitor and keep on correcting from the ground station. All right? Clear, Durgesh? This point is clear? Okay. So now what I've discussed here with respect to the orbit, PSLV and GSLV, RLV I have already covered, scramjet I have already covered in the classroom, and then part of it. So now what I would like to take you here is that you should always keep on going to the ISRO site. I'll take you to the ISRO site again. So it will come to your screen here. If you can see here, there's a screen here, right? The screen has got I have opened with the ISRO, right? So there is a see, dear friends, I have already said that whatever you have doubts or queries, please send it to the batch coordinator. If you remember the last class also I have mentioned that. But I find that even the students, they're still sending the doubts and queries in the Compton. Like here I can see that Rahul Srivastava is sending the doubt regarding the strap motors. So it is not that your doubts will not be addressed. Your all doubts will be addressed. But what happens is that all of a sudden you keep on putting the Compton and the chat box. So that basically the exactly chat box or this has been given response box has been given that you can interact with the faculties in terms of whatever I am asking and your reply, whether it is going well or not, something of that. Your doubts first should be given to the class coordinator, and the class coordinator will forward the doubt to me. I am always ready to answer all your doubts. No matter your doubt is a simple one or a difficult one, I am always open to that. But again, you maintain a kind of the way the system works, right? So Rahul Srivastava has asked me a question about strap-on motors. See the strap-on motors here. These are the motors. They are like a small rockets. They act as a booster. They are also like an engine. They are also like a rocket. Strap-on motor. Motor is an engine. What is motor? Motor is basically an engine, and that is strapped on the first stage, right? Because see here, what happens is that if the size of the satellite, right, if the weight of the satellite increases dramatically, so you cannot make a heavy rocket, right? You cannot increase the size, the volume of the amount of the fuel or the propellant. Then the storage tank has to be increased. It will become quite bulky. It will not be feasible there. So what is engineering idea? What is the engineering? I'm talking in terms of engineering part. So what is engineering idea? That on the first stage, at that time, the rocket has on the launch pad the entire weight of the rocket plus the weight of the satellite, what is called payload, right? That payload weight plus weight of the rocket, it is in the first stage, in the initial part, on the launch pad. And during the liftoff, the entire rocket has to overcome gravity of the earth, gravitational pull of the earth. Now let's say if it becomes heavier, so it will be difficult to provide necessary thrust to go outside to the atmosphere. So what is the engineering idea? That on the first stage we place such kind of a tiny small type of motor or engine. They are like boosters. They are like boosters. They act like a boosters, right? This type of boosters are there. These are strap. Strap means they are added. Strap means you join them, right? You strap them with the first stage. So what happened? This strap-on motors, which are strapped on the first stage of the PSLV standard model and the extra large model. So these also burn. It also carry fuel, and it is strapped all around the first stage of the rocket. So this also burns there. By burning, it also provides additional thrust during the liftoff, right? It has got the fuel capacity, right? Now in the PSLV, we use solid fuel as a strap-on motors to provide additional thrust in the first stage. Whereas in GSLV Mark II, if you look at GSLV Mark II here, Mk2 version of the GSLV, on the first stage we use 4 liquid-based, here I have written very clearly liquid. We use 4 liquid-based strap-on engine or motors to provide the additional thrust, because GSLV Mark II can launch 2.5 ton or 2500 kilogram class satellite. So you require more thrust. So what we do in this case, we use liquid fuel based, which is derivative of a Vikas engine, that is strapped in the first stage of the GSLV Mk2. On the other hand, if you look at Mark III, GSLV Mark III. Now GSLV Mark III, what do you find? We have 2 bigger size solid based S200, 2 bigger boosters, solid boosters are there. They are like a rocket engine only, which are placed on the sidewise with a core liquid one. You have central one here, liquid, L110, 110 tons capacity of liquid fuel. So what happens? First, these boosters will burn, will get detached. Then the liquid will burn, they'll get detached. And the last stage, third stage, we have an indigenous cryogenic engine. Here in the last one, we have a cryogenic engine. This is the heaviest one which we have built there, right? So if you go to the ISRO site, if you look at here, this ISRO site, it will come to your screen here. So here the ISRO site, and you'll find that all these launchers have been given here. You can find this is part of here, right? Which we add into that part. Then what I'm coming here, the missions. Like if you see here, let's just very quickly go into that. You have here trending Mars orbiter mission, then LBM-3X CARE, crew atmospheric re-entry experiment. Right, this is another very important mission. You can say this mission is towards Gaganyaan mission. Crew module was like dummy crew module without human beings, sent to the outer space and then dropped into the ocean. So GSLV Mark III, what we have today, right, GSLV Mark III, what we have today, initially in the earlier, this LVM-3 rocket was developed, and December 2014 it was launched. What you can see here, this is the same as it was given the name LVM-3, and we took a crew module, a small dummy module without human being, right, and launched to the low Earth orbit, and then dropped into the ocean, brought it back. The module was dropped into the ocean. So here you have this experimenter was there. So you can see here, this is the LVM-3 rocket profile. The LVM-3 was launched from the part of it, right? It went to the outer space where the booster separated. Then it has a separation of the module here. This module was separated, and then this module was dropped into the ocean. You can see with the help of the parachute, this module was dropped into the ocean. Before the actual Gaganyaan mission, where we are going to take 3 Indian astronauts to the outer space, ISRO is going to carry out the same kind of experimental testing. That is what you find here, right? So this LVM-3 that was done in way back in 2014, right? You'll find here. Now again you'll find here AstroSat, India's astronomical satellite. I have already mentioned that it's a multi-wavelength satellite developed by ISRO to study about the deep universe, galaxies, then black hole, then neutron star, pulsating star like pulsars, binary star system, supernova. All these have been studied through with the help of Astronomical Satellite of India, AstroSat. And you can see here, AstroSat, it uses 3 type of wavelength. One is the X-ray, second is the visible light, optical light, and the third one is the ultraviolet rays, UV rays. And it 15 kilogram satellite, which was launched in 2015 into 650 kilometer orbit. What is the size of AstroSat? 15 kilogram. It was launched into 650 kilometer orbit in 2015, and it is a scientific objective is this one: to understand high energy processes in binary star system containing neutron star and black holes, estimate magnetic fields of neutron stars, study birth region of the stars, what is called nebula, gas and dust, and high energy process star systems lying beyond our galaxy, that is beyond our Milky Way, detect new briefly bright X-ray sources in the sky, and perform a limited deep field survey of the universe in the ultraviolet rays. Now here this is for 5 years, 2020 was the time by which this mission has to be worked, and it has continued with that mission there. We have successfully completed 5 years of AstroSat mission. And you'll find here, you can find here this, you have a brochure also there, and you'll find the payload also there. So it has a 5, you can see these are the instrument on the board of AstroSat, right? Which are the instrument here? First is large area X-ray proportional counter. Second instrument is ultraviolet imaging telescope. Third instrument is cadmium zinc telluride imager. Fourth is soft X-ray telescope. Fifth is scanning sky monitor. These 5 instruments, and they have been developed with the help of TIFR, Tata Institute of Fundamental Research, which comes under Department of Atomic Energy, right? You have this AstroSat mission there. And then when you go back here, you'll also have a very important recent launches. PSLV C-51, Amazonia, right? Brazilian satellite which to study the deforestation in Amazon forest, right? This is a very important mission where the PSLV C-51 was used for first dedicated mission from NSIL, New Space India Limited. Last class I told that now we have got a new commercial company under the ISRO called NSIL, New Space India Limited. Earlier we have present also running with that Antrix, right from the beginning. Antrix was the commercial arm of ISRO. Now along with Antrix we have got now NSIL, New Space India Limited. Now you can see here Amazonia 1, PSLV C-51 has successfully launched the Amazonia 1, the satellite. Now, Amazonia 1 is the optical Earth observation satellite of National Institute for Space Research from Brazil, that is South America, and that is to provide remote sensing data for users to monitor deforestation in the Amazon rainforest. You know, the largest rainforest of the world is Amazon. So Amazon rainforest, and it is now getting affected because of the hydropower projects, then a lot of human development projects like which are causing deforestation in Amazon forest. 2 years back, it was in the news where Amazon was burning, right? Forest fire in Amazon forest there. So there deforestation in Amazon region that will be studied through Amazonia 1, and it has been launched with the PSLV C51. Now PSLV C51, this is the first service provided by NSIL, New Space India Limited, and then there were 4 Indian satellite, student satellite also were there. Which were the student satellite? One is the JPR Institute of Technology, Sri Perumbadur. Then another one, that's called JITSAT, GH Raisoni College of Engineering, Nagpur, another student satellite. Then comes Sri Shakti Institute of Engineering and Technology from Coimbatore, right? Sri Shakti Sat, third student satellite, and one was with Satish Dhawan Sat, SD Sat from Space Kids India. Kids, small children who are now being involved with some kind of a space program and all this. These 4 were there, and 13 were US satellite, and one was an important satellite called Netra, Sindhu Netra, to be used by Indian Navy. And what is given here is a third flight of with 2 strap-on motors. There is another configuration called DL configuration. ISRO has also developed a new configuration of PSLV, Polar Satellite Launch Vehicle, called as a DL. DL, what was this configuration? It used only 2 strap-on motors. You can see the photograph here. It used only the 2 strap-on motors. This one. Right? This was which is called DL version was there. Third flight of PSLV in DL configuration with 2 strap-on motors. 78th launch was from there. Right? Again, before PSLV C51, ISRO carried out the PSLV C50, right, 50 test, and it was CMS-01 was launched. Which one launched? CMS-01. CMS-01 from Satish Dhawan Space Center, and that is a communication kind of a satellite, right? India's communication satellite, CMS-01, that was launched through PSLV C50. And you can see here, this was 22nd flight of PSLV in XL configuration. Extra large configuration has got 6 strap-on motors. That 6 strap-on motors were used in the extra large version of PSLV, and that launched successfully communication satellite CMS-01. Now, if you just go back, I'm just discussing current aspect. PSLV C49, right, PSLV C49, we launched a satellite called EOS-01, right? 9 customer satellite from Sriharikota, and it was again DL configuration with 2 solid strap-on motors, and this satellite, right? EOS-01 is the Earth observation satellite. EOS, Earth observation satellite. PSLV C49. All these latest launches of satellites by India over the last 1 year, you have to be prepared. That's what I said. You have to connect theory with current affairs. Current aspect becomes very, very important for science and technology. All these satellite launch, PSLV C51, PSLV C50, PSLV C49 and other launches, you'll be getting through the monthly current affairs class and the document and the PT365 document and the class for that. Though I have opened the ISRO website to tell you the information from the ISRO site. Correct? Is it clear here, everybody? Is it clear what I have discussed right now? That you have to go to the all such current development which is there in the news with respect to the satellites which have been launched by ISRO there, right? So all those ones, CMS-01 or EOS-1 or Amazonia-1 or along with the student satellite, there can be even direct question asked in the exam. Even UPSC can ask you a direct question also in the examination there. So you should be aware of that. That's what is very, very important there. Now let's come to here. Let us now come to the satellite part of it here. Now what I'm coming here. Last class I have mentioned that we have INSAT and GSAT system of satellite there. It is a multi-purpose. We have developed this a multi-purpose satellite system, communication satellite system there. The first commercial launch was in 1983. We started in, this program was started, INSAT program was started in 1983. Right? At that time, ISRO didn't have the PSLV. We didn't have the PSLV at that time. We have to take the help of foreign countries. Their launch vehicles for launching our INSAT series. Initially, we took the help of America and France for launching part of it, right? So here, INSAT GSAT system here, if you look at the application part, there are even questions asked in the exam. You get direct question in the examination. We directly ask questions with respect to the application part. Now if you see here the application part of it here, the first one is the telecommunication. Business communication, normal telecommunication, mobile communication, they use the GSAT system of satellite, right? They are a heavier communication satellite. Second, what comes here, broadcasting. Broadcasting services, we use the INSAT GSAT. Like for example, here you know that a very good example is direct to home, DTH. Today we are using direct to home services. Right? Thousands of channels can be viewed by the people at home with the help of DTH. You have an antenna there which receives the signal from the outer space. Right? Then what comes the third one, distance learning, what is called tele-education. Right? Now in tele-education there is a technology called VSAT, very small aperture terminal, and you have a live classes, distance learning. Like for example, I'll just tell you the example here. Now what you are having right now is the tele-education. I am here in the classroom. I am right now in the Rajendra Place classroom of Vision IAS, and I am teaching in the classroom on the whiteboard. I am using the iPad and the laptop to take you to the website of ISRO and everything, right? The camera in front of me is the camera, right? Now the camera captures what I'm teaching there. I'm using the mic here, right? At the same time, whatever I'm writing on the board, whatever I'm feeding you through the website, through my iPad, right? That is now through the wire goes to a server. There's a server room where it gets there, and the software, there's software which creates there, and then it goes to the streaming, live streaming, right? It happens through the cloud. And all of you at your home, with your laptop, with your mobile phone, you are right now watching this class live. So this kind of a platform is called tele-education. What is called as this? This is called tele-education, distance learning. Now this is we are doing for UPSC preparation, right? This I am conducting the class, and you all are joining this class for preparation of competitive exam. But now let's look into another dimension. Primary school. Let me provide another very important. Primary school, secondary schools. Right? A maths teacher, a science teacher, right? Who is there in, let's say, in urban area. Let's say Rajasthan, just take the state of Rajasthan, right? Jaipur. A teacher of maths and science who stays in Jaipur through the tele-education can teach young children in Jaisalmer and Badmer, where we are talking about border areas. Badmer and Jaisalmer is the border, are the border areas. Imagine that the students there, just like a live class, as I am teaching in the classroom. And such children in the school, in such border areas, can attend the class live on different subjects of the school. Arunachal Pradesh, Kashmir, Ladakh, right? Kanyakumari, you take any part of the country. Not only within the country, tele-education can also be provided to other countries. Let's say Bangladesh, Nepal, Bhutan, Sri Lanka, Myanmar, Afghanistan, right? There also the tele-education can be provided. And that happens through SATCOM. It happens through satellite communication. For our neighbors, right, except Pakistan, other neighboring countries of SAARC, South Asian Association of Regional Cooperation, except Pakistan, other countries, they are using GSAT-9. What is the name of the satellite? GSAT-9. That is called South Asian satellite. And we are giving all these kind of services through South Asian satellite there. Then comes here another very important application called telemedicine. What is the application here? Telemedicine, which is done through GSAT system, INSAT system there, right? Now, telemedicine here, telemedicine system has been now developed for providing the healthcare services, right? To provide the healthcare services to people at the far-flung area. Let's say, for example, I'll give you an understanding with example. A doctor or a surgeon who is there in AIIMS hospital, All India Institute of Medical Science, AIIMS hospital, there a doctor or surgeon who is working with the such multi-specialty hospital can look into the condition of a patient in a border area, again through the video conferencing, through the telemedicine platform. So whatever the conditions of the patient is there, blood report or any kind of a report can be seen on the computer screen. And there can be live discussion, live telling to the paramedics. There may be sometimes paramedics at that particular area. You know that in villages you have a primary health center. What do you have there? PSC. Again, that can be supplemented with the help of telemedicine there, right? There's another one. Then comes here meteorological application. Like for example, when you talk about meteorology here, let's say here, for example, weather forecast, right? Forecast and warning, right? Forecasting and warning there, right? It becomes forecast and warning kind of thing. We can let's say impending cyclone coming to the coast of Odisha or let's say Andhra Pradesh or let's say coast of Kerala or Gujarat. So we can give a warning to the coastal community there, right? Of any such kind of impending or coming natural calamities there. The warning can be delayed to the mobile phone or can be broadcasted to the people in the coastal areas there. So again, for that meteorological application, forecast, warning, then disaster, this again you can connect with the disaster management support system. Let's say search, relief, search operation, relief operation, right? That can be done through such kind of satellite communication part of it, right? So we have now such kind of multiple satellites which we have developed, and you will come across when you visit the ISRO site, you will be coming across that. Recently we have launched CMS-01. Communication Satellite 01 was launched by the PSLV C-59. Now this is one aspect. Now what comes here? Another one which we have here, IRS, Indian Remote Sensing System. There is another dedicated satellite application what we have in the country here. We have again network of the remote sensing satellite or earth observation satellite, and we are using number of them. Let's say here, it was started in, I had already given you the year also, they started in 1983. Right, we started this program in 1983, and we have a lots of name here. One is ResourceSat 1, ResourceSat 2, 2A, 2B. They are advanced satellite with they have images It can capture all the data images on the ground, on the water bodies, on the ocean. Then we have for mapping purpose, we have got Cartosat for cartography purpose. Then for study of ocean, we have got OceanSat. Right? All these are examples of the, and recently you know the RISAT, radar imaging satellite. RISAT has been now developed. Now what are the applications here? UPSC had already asked in the prelims exam questions regarding the remote sensing satellite. You will find in the previous year question paper, when you go to the previous year question paper, you will find this type of question has been asked in UPSC exam there. Now look at here the applications of remote sensing satellite. The first application, right, of the remote sensing satellite is that in terms of survey and management of natural resources. You can take any such example, for example, forest, right, agriculture, whatever the natural resources are there, agricultural mapping can be done, agriculture can be done there. Not only agriculture and forest, we can also do for water bodies, let's say reservoir capacity. Now summer is coming, so during the summer we have to get the data regarding the capacity of reservoirs because of the irrigation and agricultural, for that we need water for that. Agriculture there, then water resources, wetland, let's say wetland mapping and all this one can be done. Then comes here mineral prospecting. We can use such advanced remote sensing satellite for prospecting of minerals, finding out minerals based on the rocks and the mineral there, right? ResourceSat is one such good example of that. Then comes here cartography, that is the mapping part. For that we have a very advanced type of satellite system called a Cartosat. Cartosat 1, 2, 3. Now Cartosat 3 series is we are developing there. They are very advanced multi-wavelength based cartography there, which is the mapping. We can have a dedicated maps can be prepared there. Then I have said here oceanography, study of ocean there. Let's say coral reef, we can have coral reef, then seagrass bed, right, temperature, salinity of ocean current. So for oceanography we have there. Then apart from that, we also have for environment part also there. For ocean studies, we have very important satellite called OceanSat. SCATSat, OceanSat comes into environment study. Let's say pollution. Which part of the earth has got more pollution, more emission of greenhouse gases? Where we have more such kind of pollution, we can locate such site with the help of the cameras on the remote sensing satellite there. So environmental aspect can be done. Again, it can be done for disaster management supports also there. How the disaster management support comes for the remote sensing satellite? That can be done through, like for example, here we can have a hazard map. We can prepare, like for example, hazard map. Which are the earthquake prone area, cyclone prone area, right? Those kind of maps can be developed using the remote sensing satellite there, right? Then comes here the another third very important one, that is in terms of navigation part. I had already mentioned you in the classroom there also, but again I'll mention here. For navigation purpose, we have two important systems here. First is IRNSS, which has been named NAVIC, Navigation with Indian Constellation, and that was started in 2013, right? And I have given you that there are 7 satellite systems. So here you have 4 satellites in geosynchronous orbit, and we have 3 satellites. This constellation consists of 4 satellites geosynchronous and 3 satellites in geostationary orbit. And the range here, it can cover, I have already covered this in classroom also, 1500 kilometers, entire India, it can cover India, Indian landmass, and 1500 kilometers from outside borders, from borders. That is a primary service area. Where we can have this coverage there. Now it has a another point here is that it carries the application part. Now applications here, I mentioned it has got two dedicated applications. First application is that in terms of standard positioning here. SPS. Now standard service positioning service, that is, it gives in the range, right? Can be used by civilian, right? Like for example here, civilian application here, civilian use, traffic management, locating any kind of like let's say fleet management, location of any point on, so all this one we can use the point of the standard position system, which gives a range there. It has a range of 20 meters. Like here, it gives the accuracy of 20 meters there. And second comes here, restricted positioning service, which is basically exact, restricted positioning system, which is for some decided users like Army or Air Force or Navy, government use there. Like here, for example, military application. In terms of missiles, rockets, and fighter crafts. So for that, we can use the NAVIC system here, right? It has a resolution, like here, the range, if you take range here, range of 20 meters, it can provide the data there. And it carries the cesium clock also there, right? In the INSS part of it. So that is another one which we started in 2013. The launch of the satellites we have started, and now we are expanding on the part of the satellite network. Now there is a question from Hemant Srinivas. He is asking a question that, does traffic jam or collision problem happens in 35780 kilometers orbit, as many communication satellites are being parked in that orbit? How we are managing that? That is managed with the slot, right? What Hemant is asking is a very valid question. That we are going to use geostationary orbit. Now there are two aspects you have to know that. That again depends on the location of the country. Let's say India, right? We have to cover the communication part on the Indian landmass. So in a geostationary orbit, the satellite has to be fixed at that particular point in the sky, in the outer space. So that signal from India, any part of India can go to the GSAT, the communication satellite, in the geostationary orbit and return back to the Earth, back to the country. Right? So it depends on first location. Accordingly, we will park or place the satellite. Second point here. Second is that it is an equatorial plane, not necessarily always 0 degree. It can be tilted also. Right? Let's say India. India is a tropical country. Our country lie above equator. We are above the equator. So though the plane of the equator, plane of the orbit will cut through the equator. But it has to be a bit inclined so that the satellite which goes around in that orbit is focused to remain stationary with respect to India. So there are two ways are there in terms of the 35,074 kilometers. One is the position of the country with respect to that you are fixing there, that slot, right? And second is that when you talk about geostationary, equatorial plane, it can be tilted also there. There can be different orientation. So you can park on that circular orbit at different position, you can park it, right? And at the same time, if you are slightly inclined 1 degree or 2 degree, again you can park on that particular orbit there, right? Another very important thing, every communication satellite has got a lifetime. Third very important point is the lifetime. It has got a mission life of 10 years, 15 years, 5 years. When the satellite becomes older and we have increasing demand of more services, what are services? What I mentioned there. When there is more increasing demand of services and the satellite becomes old, then we take that older satellite and bring it lower to the low Earth orbit. We bring it down. That is what is called as the junk, space debris. So that the slot get cleared and we can insert the new satellite. What countries do when the satellite becomes older or we have to replace with a new one to meet the rising demand of the services, then the older satellite is brought to a parking orbit. It's brought to a kind of lower orbit so that that slot is empty, vacant, which can be occupied by new communication satellite. Clear, Hemant? Is it clear how we manage? Hemant has asked the question, so I have just replied to that question there. Now what I'm coming here, all these have been asked in UPSC exam. If you look at previous year question paper, prelims exam, main exam, all these have been asked. But what I'm now coming to a topic where you can expect the question, that is a Gagan. Gagan and Bhuvan. We'll now discuss two important systems developed by ISRO, that is a Gagan system and Bhuvan system, right? And with that Gagan, we will also discuss Gemini or Gemini. I will be discussing that part. So let us now go to the very important area called as Gagan satellite system. In terms of navigation, it comes with Gagan system, right? So first of all, if you have copied this one, then I'll clear the whiteboard. इनको पूरा दिखा दीजिए. Any doubt you have with respect to INSAT, GSAT or IRS or all these areas? Have you copied from the whiteboard? Please, whatever points I am writing on the whiteboard, you just copy that as a part of your class notes. We will now discuss Gagan and Bhuvan platform. And then after that, we'll go to NISAR. We'll discuss about NISAR, NISAR, NASA ISRO Synthetic Aperture Radar. Okay. So I'll clean the whiteboard then. Now let's come to this part. But again, remember that whatever the latest satellites in the case of remote sensing or communication satellite, you have to cover from the current affairs. And I'm very sure that monthly current affairs classes would be discussing all those latest launches of satellite by ISRO or whatever the worldwide development is there, right? So now let's come to here, Gagan system. Gagan is important for the examination, right? So far, UPSC has not asked a single question on the Gagan satellite system built by ISRO. So let us now understand here Gagan system. Now Gagan stands for GPS aided geo augmented navigation satellite system. That is called Gagan. Now it is a joint project. Gagan is a joint project of ISRO and Airports Authority of India, AAI. Right? So this project has been, Gagan system has been developed with the support of AAI for meeting the demand of the domestic civil aviation, right? Now, but we can use for other application also, but primarily meant for the civil aviation there. But we can use for other application as well. I will discuss that other applications. So Gagan stands for GPS aided geo augmented navigation satellite system, right? Now what is Gagan here? It is not a completely purely GPS. We will not call it as a GPS. We will not call it as GPS. It gives the navigation. It also provides the data, But with the help of GPS of America or other country, it takes the data and relate to the pilot flying the aircraft. So what is here? Gagan. So Gagan is the first one, is that to provide a civil aviation sector in the country dedicated navigation services. With the help of three communication satellites. Here we use three GSAT. The three communication satellites are there. What are their names? They are GSAT 8, GSAT 10 and GSAT 15. So what is Gagan system? Is basically to provide civil aviation sector in the country dedicated navigation services with the help of three communication satellites. We are using here three communication satellites, GSAT 8, GSAT 10 and GSAT 15, right? Which provide the data of GPS from the American GPS. It just gives. So the three communication satellites which provide signal in space. Signal in space to aircrafts. Right? Now the signal of GPS is taken by these three communication satellites. It provides that. So it is this kind of system is called, there is a special name given. It is called SBAS. That is satellite based. It is called, communication satellites are used here. It's called satellite based augmentation system. Satellite based augmentation system. Now there are other SBAS worldwide also. Japan also use the satellite based augmentation system. America also use the SBAS, right? European countries also they use SBAS. So there are worldwide different SBAs are there, which basically use set of communication satellite to provide the dedicated navigation services to the aircrafts. So it boosts the signal. So what happens here is that, let's imagine here, an aircraft, right? Then an aircraft which is there in the air, right? Let's say this aircraft which is there in the air. So this aircraft which moves in the air, it gets the continuous signal, the pilot in the aircraft will get the signal from where? The GPS system is there. You have a constellation of satellite here, GPS, right? So here the signal which is relayed, right? Signal which will come to this part and to the cockpit where the pilot flies the aircraft. Sometimes the pilot has to also receive signal from the ground here, where you have on the ground here, let's say you have a tower. You have a ground from where, let's say you have a air traffic management, air traffic control, air traffic control and management. Now this signal also reach to the pilot here, air traffic control and management here. Now sometimes because of bad weather or bad signaling, a pilot may not receive the signal, and that would the pilot will not be able to take decision, right, whether to land or not. See, a pilot which fly the aircraft in the air again is guided through the GPS only. So let's say the change in the height of the plane or the direction of the aeroplane or the landing in the airport, it all gets that signal from the air traffic controller. There is a air traffic controller in the airport which gives the signal to that part. Now sometimes bad signal or not having proper signal, it can create problem for the pilot in the aircraft in terms of the landing operation or changing any direction. So what is done here is that Now, whatever the signals are there, now we have developed here Gagan. What is Gagan system? Gagan system is made up of 3 communication satellites. We have a 3 communication satellites there. So what it can do is that the signal can go to the Gagan system, and then from there it can be sent back to the pilot to the aircraft. So instead of going directly to the aircraft, which can have sometimes, it can go via Gagan, or the Gagan can take the GPS, like here. The GPS signal, it can go from GPS to the Gagan system there. So what happens then? It augment. What is the word here? Augmentation. It augments the signal of GPS or any signal coming from the ground station with the help of communication satellites, right? And our Gagan, this augmentation system, and also here, this is called satellite-based augmentation system, SBS, which is connected with other SBS worldwide. Let's say civil aviation sector, an international flight from India is going to, let's say, Dubai, or is going to France or UK or USA. So then the signal still can happen through the other SBS of the same type by the other countries. Now what are the advantages here, the benefits? What benefit it gives here is that, of having such kind of a system is that, the first benefit is that it provides proper signaling, provides better signaling to aircraft, right? Even in the bad weather, right? So it provides better signaling to aircrafts, right? During bad weather or some there. Second is what? It enhances safety during takeoff, right? Vertical movement. Sometimes the vertical movement in the air happens, vertical movement in air, and landing. Like sometimes bad weather, the landing will be difficult on the runway there. So landing of aircrafts. The second advantage or benefit of using the Gagan system, it enhances safety during the takeoff, landing, and the vertical movement in the air. Another one here, third one is that provides signaling, right, during oceanic en route, because sometimes over the ocean there may not be enough of the signal coming there, and that can lead to a problem, like you know, accident could be there. Malaysian airline MS371, it just went off into the and went down into the ocean there. Oceanic en route, right? It saves fuel by minimizing circulation time, by minimizing the circulation time of aircraft. What is the next point of benefit here? The circulation time. What is circulation time? When an aircraft comes to the airport, near to the airport, if you have any time traveled to a very busy airport, let's say Mumbai is a very busy airport, right? Delhi is a busy airport. So what happens in airport? There may be sometimes limited runway. Let's say you have only 2 or 3 runways, and let's say number of flights are taking off and landing there. So the air traffic controller has to manage the entire air traffic there. The runway has to be cleared for takeoff and landing part, right? Let's say you are arriving to the Mumbai airport, right? So what will happen? The pilot, if it doesn't get the signal for landing to the runway, so what the pilot will do? Pilot will keep on circulate, it will just keep on going around and around in the same area. It will not land there. You would have sometime realized this kind of, if you have traveled by air and if it has happened to you there, that it keeps on circling around in the air. Now, if it is circles in the air, let's say 5 times or 6 times, it has to burn the fuel, aviation fuel. So that is the fuel is getting wasted. The fuel is getting wasted because of circulation. Now, let's say one scenario I have said, busy airport, limited runway. Now imagine that. You have runway also and there is no traffic. But because of bad weather, because of during winter time, during rainy time, rainy season, the signal get attenuated, particularly in the rainy season, cloudy rainy season, or let's say bad weather condition. The signal is not proper. Even though runway is vacant, runway is clear, but since the pilot who is flying the aircraft is not able to receive the proper signal, the pilot will not take risk. Again, what the pilot will do, will keep on circling. So that is what I have said here. It saves fuel by minimizing circulation time of aircraft. Right? That is what the point I want to make here. Then again it helps in air traffic management. These are the benefits of using Gagan system which has been now developed there. But it can also be, this system has been developed for airports, but we can also use Gagan for other application also there. And you will find when you visit any of the now airport, you'll find Gagan is given there. There will be some kind of advertisement or some kind of area where Gagan will be written there. So what is UPSC exam? An IAS exam or a UPSC exam is that exam which basically tests what is going around you, what you see around, what you read, what you hear, what you watch, sometimes in the newspaper, on the TV channel or the mass media or places where you visit. Let's say when you're going to airport, you'll see somewhere in the side was written Gagan, right? Some showcase over Gagan. So you should, then UPSC can ask question there. Do you know what is Gagan is all about? And based on that question can be asked, right? Recently, there was another very important aspect of the Gagan that is called Gemini. Right? There was another thing called Gemini. It's a Gagan based maneuver device. Here, what is Gagan? What is Gemini? It is a Gagan enabled handheld mariner's device which has been developed based on the Gagan technology. Now what is the thing here is that this particular technology used by fishermen, right, to find out, I'm writing here very important word here, potential fishing zone, PFZ, potential fishing zone, PFZ, where the catch will be more, right? This handheld device called Gemini can be used by fishermen in the coastal area to find out PFZ, potential fishing zone, where there will be more catch of fish in the sea and ocean. So that can minimize the time of the fishermen going out in the sea there. And they can go for more catch, right? So potential fishing zone at the same time and provide warning, provides early warning for like storms, high tides, right, bad weather, right, in the ocean, sea and bad weather, or it can be cyclones, super cyclones, or let's say bad weather, right, etc. So it can be conveyed to the fishermen through the Gemini device. So it can provide early warning for storms, high tide, cyclone, etc. in advance, right? So that the fishermen will know that now it is very risky, the risk of going to the outer sea. So they will avoid going to the outer sea. in case of bad weather, cyclonic event or some kind of a wind, high speed wind or storm. So that can also save lives of the fishermen, right? So that is where the Gemini has been developed. And if you go to the part of web page, current aspect and all, you'll find that. I'll just take you to the current aspect here. I'll just connect through my iPad and take you to that part. Let's say, for example, here. Gemini, Gemini, PIB, Press Information Bureau, right? Now see here, it has come in the Hindu paper also there. Satellite-based advisory services launched for deep sea, right? All this you'll find here. ISRO also you'll find in that case there. Gagan-enabled, let's say here, Ministry of 2nd January 2020, last year, like almost 1 year back, it was making headline. And UPSC had not asked there. Another point is that when something is very highlighted in the news, which everybody is knowing about it, that year UPSC doesn't ask question. You'll find the question on the same topic, on that topic will be asked after 2 years or 3 years. Now Gemini was in the news, but now at that time last year, question was not asked in the exam. Maybe possible this year you could get question there. Now you see here. Gagan enabled this one. Or let me do one thing here. I'll take you to the images, infographic, that will be more better. Now look at here this way. What is given here? Gemini is a softbox sized device fitted to fishing boats. Where this device is fit? Is fitted to the fishing boats, which will have with a receiver. Servers in INCOIS Hyderabad. Hyderabad has got a very important research center that's called INCOIS, Indian National Center for Oceanic Information Services, INCOIS, which comes under Ministry of Earth Sciences, under MOES, Ministry of Earth Sciences, on various ocean parameters including sea surface temperature, current and wind speed and direction. The Gemini device can give the information. Then numerical models to generate a forecast on a daily basis, daily weather. It can be daily weather forecast given to the fishermen. Disaster warning for cyclone and tsunami, even for tsunami also. Tsunami warning can also be given there. And potential fishing zone, PFZ. The forecast is transmitted to Gemini device receiver through Gagan. Gagan system satellite, which use 3 satellites, GSAT 8, 10 and 15, will provide the signals to the device Gemini in the fisherman's boat. Then you can see Gagan is used by airport and all. I have already discussed that. Gemini sends this information to a mobile application through Google Play Store. The fisherman can download an application, Gemini application, and send the information to a mobile application downloaded by fishermen through Bluetooth in all regional languages. All regional languages. Imagine that. Here the languages, that means a fisherman in Tamil Nadu, or in Andhra Pradesh, or in Odisha, or in West Bengal, or in Kerala, or in Gujarat, or in Maharashtra, Goa, whichever state, in the regional language can get the information. Right? So PFZ forecast can be sent 3 days in advance. 3 days in advance, where there will be more catch of fish in the ocean, this advanced information can be given. Alert on weather systems are also sent once every hour. Weather alert is given once every hour. Now this is what the Gemini is all about. Right? It has come into all the news and all this. You will find all the news and all this, you have this particular information given. Alright? So I have discussed a very important one called as here Gagan system there. Any doubt you have? Anything you want to ask on Gagan? No doubt. If you don't have any doubt, then I'll go into the another one called Bhuvan. We'll discuss about Bhuvan platform. But I'll demonstrate with an example. Okay, now let's look at here. I'll take you to Bhuvan platform. There's another very important platform. Have you all written there? All have copied this information on the whiteboard? Have you copied all this on your whiteboard? From whiteboard, have you copied in your note copy? Okay, please ask to focus on the board. बोर्ड में फोकस कीजिए आप. एक बार और आप शो कीजिए आप. आई एम आस्किंग द कैमरामैन. And Gagan is important, right? This is important for the exam. Let me mark here. This is important for the exam. Okay, a few of the students are asking for break for 5 to 10 minutes. So I'll give you a break here. After the break, we'll discuss about Bhuvan platform and NISAR, NASA ISRO Synthetic Aperture Radar, right? So there's one doubt has come from Rishabh. Rishabh has asked one doubt there. Can we avoid such landing problem by vertical landing concept? And is it possible to have such type of technology on civil aircraft? See, vertical landing, I'm not talking about vertical landing, I'm saying vertical movement. I'm saying here vertical movement. I'm not saying vertical landing here. Rishabh, try to understand there. Vertical movement can be like this. An aircraft which take off can continuously go in the air. So this is also vertical movement, right? If this is the surface and this is runway and the flight takes off. So if flight takes off, it can slowly can go up in the sky. So there can be vertical movement, this vertical movement. I'm not talking vertical landing. And then I've written here, vertical movement in air and landing of aircraft. They're two separate words. Rishabh, they are not the same term. I'm using three words here. First is the takeoff. Takeoff of aircraft. Second, I'm saying after takeoff, there will be vertical movement in the air. And then third scenario is the landing of the aircraft on runway. Right? When the aircraft land on the runway. Is it clear here? I'm talking three different scenarios. During the takeoff, as it slowly goes in the air, vertical movement, and then when it is coming to the airport, landing. So there will be what? Vertical ascent going upward. And when it has to land, there will be vertical descent going downward. Now Rishabh is also he is asking can we avoid such landing problem by vertical landing concept? Right, what Rishabh is saying that, can we avoid such landing by vertical landing concept? And is it possible to have such type of technology on civil aircraft? See, helicopter. What does the helicopter does? Helicopter can go just vertically up and vertically down by rotating its blade. And helicopter can also hovering in the air, can stay in the air with respect to its movement of the rotor blade. Aircraft as of is not there, but yes, in future, scientists are working to develop a technology which can be both aircraft and helicopter. Rishabh is saying that can we avoid such a landing problem by vertical landing concept, that like this one. It can be done, that is also kind of scenario can be done. I'm saying can be done, but presently it is not possible. Presently it is not possible. Yes, maybe after 20 years, 30 years or 50 years, a new technology can be developed where the flight landing, सीधा, नीचे. Like a rocket. Rocket goes with that, just like they're going up and then नीचे सीधा, like a helicopter. That will happen in future, not present. Right? Not happen in present. Right? So such type of technology on aircraft can be worked out. And please, please forward when whole concept get this. Okay, I have done that. That can be in future. You are right, Rishabh. That can be done. Scientists are working on that. Who knows? In future, it can be possible. Like a helicopter. Technology is being worked out, but today it is not there. All right. Okay, guys, let's have a small break, and we'll come back. All right. Let's have a tea break and return back. Okay, we'll resume back. I said that I will be discussing Bhuvan. Now, Bhuvan platform is the two-dimensional or three-dimensional geo portal of ISRO. Let's go to Bhuvan portal. I'll just demonstrate with certain examples of Bhuvan. Then I'll give you the points on whiteboard here. When you visit the Bhuvan website, even you have a mobile-based app also there. From Google Play Store, you can download the Bhuvan app. Bhuvan app is like similar to Google Earth. As you have seen Google Earth, same way it works there. Now what is here in this case is that, let's say this is the Bhuvan web page. Let's say for example deltas of India. Right? It gives you thematic area. Number of thematic area, the maps are given here. Let's say Bhuvan here, it gives you deltas, this deltas of India. You have examples here. Now let's look at here. Select, like left hand side you have a where you can select there, like Mahanadi. Right? And it will take you to the aerial map of Mahanadi. You can see the Mahanadi delta. The yellow color is the border of the delta. Where is Mahanadi delta? Mahanadi river meets at Cuttack. Right? Cuttack town of Odisha, where Mahanadi meets the Bay of Bengal. Right? I have been to Cuttack there, Cuttack and Bhubaneswar and all places I have been. Bhubaneswar and Cuttack, they are like twin cities. Right? So Mahanadi Delta, like you can see the photograph here, district boundary. If I just click on the district boundary, it gives a district boundary, then block boundary you can see here, then village boundary. Google Earth will not provide you district boundary, block boundary or village boundaries, it will not be provided. But Bhuvan platform can provide that. Right? Now let's look at another one. I'll take you to Sundarban Delta, 24 Pargana, South 24 Pargana, Sundarban Delta, which is part of West Bengal and goes to the neighboring country, Bangladesh. Now if you can see here, this is the Sundarban Delta, which you know is the delta of two major rivers, Ganga and Brahmaputra, right? Ganges and Brahmaputra there. Now see here, for example, I have to get the district boundary of Sundarban Delta. So it can provide me the district boundary, block boundary. Right? In South 24 Pargana, you find this map given here. Now, whatever the areas which have been affected by any kind of, let's say for example here, disaster specific database, annual flood inundation, right? Because of the, so let's say 2014, you can add 2014, 2013, year wise you can get the, let's say, if I click on this, 2014. You can see that this is the area which is flooded by this one. And you can zoom out also there. You can zoom out. Now this is the delta there. Right. So this is just like a GIS application, right? Like here, Geographical Information System, you have this application part, right? So you can have all such information through the Bhuvan, right? Now let me take you to another thematic area of Bhuvan. Let's say, for example, environment and forest. Environment and forest here. Let's say, for example, I would like to know, for example, tiger reserves. So I can find out there. Let's say, for example, today is the World Wildlife Day, right? Conservation and Survey. Today is World Wildlife Day. 3rd March is celebrated there, and you can find here. See, you have a wetland given here: Harike, Kanjli, Keshapur, Miani, then Husainwala, then Nangal, then Ropad, right? Then you have a mangroves, coral reefs, botanical gardens, biosphere reserve location, Agastya Mala, Kutch, Nilgiris, all these are given there. Let's say, for example, I would like to know Agastya Mala. Agastya Mala Biosphere Reserve, that is a part of 4 districts, 2 from Tamil Nadu and 2 from Kerala. Kanyakumari district of Tamil Nadu and Tirunal Valley. Tirunal Valley and Kanyakumari from Tamil Nadu, and Kollam and Thiruvananthapuram from Kerala. There you have Agastya Malai or Agastya Mala, the range is that, right? Let's say, for example, I would like to get the Kutch in Gujarat, Ran of Kutch, Kutch in Gujarat. Now you can see there is salt desert. White in color, you can see the salt. There is a salt deposit there. This region is the Kutch of Gujarat, right? So you can have a look into that. Let's say forest, I have mentioned, environment, you have the data here, like for example, EIA, Environmental Impact Assessment, like mining, all mines. So you can find the mining areas also there. Wildlife, let's say for example, wildlife. You have Bhuvan school also, like you can tag a school under the Bhuvan platform there. Let's say for example, Project Tiger. That Project Tiger. So it will give you the map of all the important Project Tiger based tiger reserves. You'll find in the map there. It's just still loading there because of the. Okay, I'll again try it again here. So let's say wildlife here, and I'm just clicking on Project Tiger. 1973 Project Tiger, and you'll find here. So this all has come there. Corbett, Dudhwa, Valmiki, Pench, Indravati. See that? Sahyadri, Sundarban. It gives the marking on the map of India. Project Elephant, if you want to know about Project Elephant, you can find out there. So Bhuvan is a very dedicated platform where you have census data, you have deltas of India, environment and forest, NVIS, then you have a CRIS, then you have a flycatcher distribution, island information, school Bhuvan, toll plaza, toll information you have, groundwater, pipeline grid, watershed development program. You have for tourism also there. You have a dedicated Bhuvan for tourism, right? It can give you the tourism part of archaeology part of also there. Archaeology, then urban areas, right? Let's say monuments, right? Monuments here. Like for example, I'll just give you one last example using the Bhuvan here. Let's say for example, if you go to the monument of which state you want, let's say Delhi, and in Delhi circle I'll select the Delhi circle, let's say Delhi circle. Now I have to select the district here. Let's say let's select south district of now you'll have here left hand side names of the monuments there, right? Like for example, you have all the names given here. Area between Balban Khan's tomb and Jamal Kamali, then Baghe Alam Gumbad with the mosque, Bandi or Poti ka Gumbad, right? Bauli, Munir Bara Khamba, Begumpuri Masjid. You have all the name there, right? Bibi or Dadi ka Gumbad, right? Chor Minar, Choti Gumti, you have all of them, right? Haj Khas building also you'll find there. So you have all the Idgah of Kharehara that is given here. Kala Gumbad, you have all those names which are in South Delhi, you have in terms of, you'll find that. And I can select one, let's say for example, Qutub Minar, Qutub Archaeological Survey Area. Now this is the map, right hand side you can see the map. Qutub Minar map has come up there, right? You will find all the locations mentioned here in the Qutub Minar area, right, in South Delhi. So this is the way Bhuvan work, and why it is very important for all of you. 2009 this Bhuvan platform was launched by ISRO to provide 2-dimensional and 3-dimensional geoportal information. There are more than 5,000 maps which are on the Bhuvan platform, and it can be used for various GIS applications, geographical information system there. And today ministries and departments, they are using Bhuvan platform, right? Now I'll come to the whiteboard. Now I'll provide you the information on the whiteboard about Bhuvan. So this was started in 2009. Right, Bhuvan platform. And it is also important because so far in UPSC exam, UPSC has not asked any question regarding Bhuvan platform, right? So I have demonstrated here live in the classroom, and now Bhuvan here started in 2009. Now what is the first point here? It is the 2-dimensional, 2D and 3D geo portal, right, which provides GIS, geographical information system, of any locality, any area you want to know, just like Google Earth, but it has more inbuilt features into that, which I have just demonstrated on the website. Geographical information system, all the detail can be obtained from the Bhuvan platform there, right? So what is Bhuvan? Bhuvan is a 2-dimensional and 3-dimensional geo portal which provides GIS based information to public, to people there, right? In various areas, there are many such areas are there. Like here, it provides more than, as I said, 5,000 maps and information. The data is there on different thematic areas. That is given through the Bhuvan platform, different thematic areas. Such as, thematic areas such as, what all areas are there? I have mentioned that census, watershed, you can get on agriculture also there, then monuments, right? Then apart from that, what I have done here, let's say agriculture, you can find out paddy cultivation, then in terms of forest information is given there. Then in terms of not only agriculture, forest and the water bodies, as I said, deltas, you can find out there. Then in terms of schools, right, environment. So a lot of such areas have been, features have been built up in the Bhuvan platform, right? So it has already completed 12 years of existence, which is given through the Bhuvan platform. Now what I am coming here, another very important future program of ISRO, that is the NISAR, NASA ISRO Synthetic Aperture Radar. I will show you in the NISAR one. Now this is the very important one from again a UPSC exam point of view, that ISRO and NASA has come together in terms of developing this important satellite, which is joint project of the NASA US agency and the Indian Space Agency, ISRO. Just like remote sensing satellite, right? It carries a radar. It's called synthetic aperture radar, and through the wavelength, the radiation, it is able to do the mapping regarding the natural calamities. So this is the web page, right? So it is projected launch is 2022. NISAR has been projected to be launched in 2022, and it stands for NASA ISRO Synthetic Aperture Radar mission. You can see the image here, and it will provide unprecedented view of the Earth, dynamic surface and interior of the Earth. It's going to be a very advanced satellite, right? It will give the information about the Arctic and Antarctica, that is a permafrost, that is in the cold areas, cold region of the Earth. It will also provide information of terrestrial ecosystems, let's say forest or wetland or river or lake, then water bodies. It will provide that information, and the entire team is working for development of that. And you can see the photograph here. NISAR will be the first radar of its kind in space to systematically map Earth using two different radar frequencies. Frequencies of radar is basically measured given some kind of range. There's something called bandwidth, L band, S band. So the two bands are there, lower band and strategic band, L band and S band, to measure changes in planet surface less than a centimeter across. Synthetic aperture radar refers to a technique for producing fine resolution images from a resolution limited radar system. Right now, ISRO has joined this mission program, and you will see here. Let me show you the and we will use GSLV. We will use the GSLV Mark II to do all the mapping and everything here. You can see here the crater and all, this all will be done there. Natural disasters, it will study natural disaster, then melting of ice, like because of climate change impact, the melting of ice and snow will be part of it there, right? So now let's look at here, and I will just so this is how you, quick fact is there. This is how the satellite will look like, right? I hope you are able to see this in your screen, and we are going to use GSLV Mark II for this particular mission there. the animation of how the launch will be carried by ISRO using GSLV Mark II, and then in terms of deployment, it will take 11 days in the orbit for NISAR to be completely, getting operational there. So now let's come to the point which I have just mentioned here about NASA ISRO synthetic aperture radar. So this is planned for 2022, right? So first one, joint project of American Space Agency, NASA and ISRO to build and use, right, or remote sensing is again Earth observation, remote sensing satellite with there will be radar, just like a weather radar or military radar is there, with a synthetic aperture radar. They will have with a synthetic, what is called SAR, synthetic, that is man-made aperture radar. Aperture means how much the wavelength it can capture. That is where the aperture comes into radar. Working with here radio frequency, there are two radio frequencies are there, working with L band, right, polarimeter. There will be polarimeter here. This L band polarimeter will be provided by NASA. And there will be S band polarimeter for study of all the feature on the earth, that will be given by ISRO, right? So first point is a joint project of NASA and ISRO to build and use a remote sensing satellite with a synthetic aperture radar working with L band polarimeter and S band polarimeter, right? Now what is the second point here? This will be to be launched, you have seen in the documentary and the video, to be launched by GSLV Mk2, which has 4 liquid based boosters in the first stage. First stage solid fuel, the core one is solid, and you have 4 liquid based strap-on motors. You have seen in the animation there. To be launched by GSLV Mk2 into which type of orbit? It will be launched into sun synchronous polar orbit. It will be in the polar orbit, right? And it will be in low Earth orbit. In low Earth orbit, that means the height will be here around 700 kilometers, just like a Earth observation satellite here. You will find that is given here. If you see the quick fact here, I'll just zoom out here, you can see here. (747 kilometers). Orbit will be inclined by 98.4 degree. So that is in low Earth orbit at altitude. Here the altitude, I am giving the precise information. Altitude of 747 kilometers. And the inclination will be 98.4 degree. So it will, one revolution of the satellite in this kind of orbit will take 12 days, right? And you will find here 6 a.m. to 6 p.m. orbit control. Now these are not very important. 5 years lifetime will be there. Right? L band will have 24 centimeter wavelength. S band will have 9 centimeter wavelength here. And resolution will be 3 to 10 meter resolution will be there, right? And what you find here, what is the objective here? I have just mentioned that to be launched, this is the objective. What will be the objective here? It will do the measurement of Earth's changing ecosystem. It is going to be the environmental satellite. You can say this will be the environmental satellite of India and also America. USA will, NASA, since it is a part of the project there. So ecosystem changes, dynamic changes on the Earth's surface. That will be measured through the NISAR project there, right? So what are the objectives of this mission? So the third point here is that objectives of the mission will be here following. The first one is that it will do the measurement, right, of Earth's changing ecosystem. Measurement of Earth's, that is dynamic kind of ecosystem, changing ecosystem. Let's say, for example, deforestation, forest fire, right? Forest fire, deforestation, which changes happens in the ecosystem like forest. Then surface changes, dynamic surfaces. Land features and all this. Then comes here very important, and ice mass, let's say Arctic and Antarctica, right? Melting of glaciers, melting of polar ice, right? Then will also providing information. This will be providing what type of information? Providing information about or data about biomass. Providing information about biomass. What is biomass? What do you mean by the term biomass? Biomass is a dry organic weight or dry organic matter, plants and animals, that is called biomass. Biomass, then natural hazards, natural calamities, earthquake, landslides, right? Floods, forest fire, all this one. Sea level rise, SLR, climate change and the impact of climate change in terms of sea level rise, SLR, right? And also groundwater. It will also study about changes in the groundwater. Now you know, because of the more consumption of water, demand of water rising in the urban areas, groundwater is getting depleted, right? And there will be other type of applications also there, right? Now, so that is where the first thing comes into in terms of the Nisarg visit. So it will observe land and ice covered surfaces, observe land and ice covered surfaces like glaciers, or I have said here polar ices, ice cap there, surfaces globally, worldwide, with 12 days time period, with 12 days regularity, at 12 days interval, right? You can say 12 days regular interval. There will be regular at interval of 12 days, this type of measurement will be carried out, right? Interval there, right? It will do all the sampling of the Earth system there. So on an average of every 6 days for a baseline year of 3 mission, 3-year mission program is there, right? It has got baseline of 3 years, mission program is there. UPSC exam is very simple exam. It is not a difficult exam. If you know important facts, and those facts will be given in the question paper, in the question there. If you can understand this one about Nisar, you are done. You will not miss the question. UPSC question setter will ask question based on this kind of information, right? So Nisar is an important, I'll mark here, this is important for the examination. You could expect question in the exam, right? So I'm giving you all such information which are important for the exam. Now what I would like to do here is that I mentioned that about Aditya mission there and about the space program there. Now let's look at here Aditya L1 mission, which I talked about in the classroom here, and the objective part, but I'll give you the point here. Let's watch this.
इसरो आने वाले 5 सालों के भीतर 5 बड़े मिशंस पर काम कर रहा है। ये 5 मिशंस है आदित्य L1, जहां पर सूर्य को स्टडी किया जाएगा, जिसके बाद गगनयान मिशन और मंगलयान 2 मिशन, चंद्रयान 3 मिशन और साथ ही शुक्रयान मिशन। इन 5 मिशन पर लगातार इसरो के तमाम वैज्ञानिक मेहनत कर रहे हैं और मिशन की तैयारी पूरी कर रहे हैं। लेकिन अब हम बात करते हैं आदित्य L1 मिशन की। ये वो मिशन है जहां पर भारत पहली बार
There is a Rajya Sabha TV also based Aditya mission.
Ban Ki Baat address on Sunday, Prime Minister Narendra Modi spoke about the ISRO's plans to launch its first sun mission, Aditya L1. This ambitious plan of the Indian Space Research Organization will not only put India in a very elite league, but also at the very frontier of cutting-edge research. With Aditya L1, ISRO will take a huge step forward in the study of solar corona. The solar corona is the outermost part of the sun's atmosphere. It is usually hidden by the bright light of the sun's surface. The 400 kilogram class Aditya L1 will carry 6 scientific payloads that will be inserted in a halo orbit around the Lagrangian point 1 or L1. Incidentally, L1 is 1.5 million kilometers from the Earth. Our focus today will be all about the impending sun mission of ISRO. We will also look at some of the prominent missions undertaken so far to unravel the mysteries of solar space and also the journey of ISRO itself. In the year 2020, Indian Space Research Organization is looking to cross new frontiers. After a successful moon mission in 2019, the space organization is now eyeing to decode the sun. The ISRO is planning to launch an ambitious solar mission, Aditya L1, in the coming year to study the mysteries of the sun. Here are the details. Just months after the successful launch of the ambitious moon mission Chandrayaan-2, India has set its sights on the sun. Indian Space Research Organization will launch its maiden solar mission Aditya L1 to unravel the mysteries of the celestial body that sustains all life on Earth. Speaking about it in his last Mann Ki Baat program from 2019. For 2019, the Prime Minister said that India is quite advanced in the field of astronomy and ISRO has taken path-breaking initiatives.
सूर्य के बारे में रिसर्च करने के लिए इसरो आदित्य के नाम से एक दूसरा सैटेलाइट भी लॉन्च करने वाला है। खगोल विज्ञान को लेकर चाहे हमारा प्राचीन ज्ञान हो या आधुनिक उपलब्धियां, हमें इन्हें अवश्य समझना चाहिए और उन पर आज हमारे वैज्ञानिकों में केवल अपने वैज्ञानिक इतिहास को जानने की ललक दिखाई पड़ती है, बल्कि वे एस्ट्रोनॉमी के भविष्य को लेकर भी एक दृढ़।
The launch is scheduled for mid next year. On board Polar Satellite Launch Vehicle. Conceptualized January 2008, Aditya L1 mission was originally named Aditya 1. It was initially conceived as a 400 kilo class satellite carrying one payload, a coronagraph. However, the enhanced Aditya L1 will be carrying 6 payloads. The satellite will be inserted in a halo orbit around the Lagrangian point 1 or L1, that is roughly 1.5 million kilometers away from the Earth. Being placed in L1 position gives the satellite the major advantage of continuously viewing the sun without any eclipses. Originally, the main objective of the Aditya 1 mission was to study the solar corona. However, the Aditya L1 mission now plans to carry out experiments to study other layers of the sun's atmosphere as well. Other than corona, it will also study sun's chromosphere, photosphere, the particle flux emanating from the sun and reaching the L1 orbit.
New name meaning, this name was given somewhere around 2019. This mission was started, the sticking started from 2017. Initially, they thought of a very small satellite, only a 400 kilogram weight satellite to be put on Earth's orbit to study sun. But then when people looked at it, they found that there are very interesting questions of sun. So then the ISRO and the Government of India decided that we'll go for a full-scale study of sun, one full-scale space laboratory.
I'm not playing the entire video, just I played the main part of it. I have already covered that. I have already covered this in the classroom about halo orbit and L1 point and This I have already covered in the classroom. Now what I am doing here in the classroom here is that as part of your class notes here, ये projector बंद कर दीजिए. All have copied this one. All of you have copied this particular Nisar one. Now we are getting to the last part of the space science and technology. So what I'll now give you in the classroom here, we'll discuss about the ISRO's astronomical projects. I have already covered in the classroom, but again I'll put the whiteboard and give all the mission objectives. All have copied this Nisar one. Nisar is copied by everybody. Okay. So let me clean the whiteboard then. All right. So now let's come to the other missions of ISRO. So we'll cover one by one. So astronomical missions of ISRO. The first one which we are going to discuss is that about lunar mission. And we have already covered there, but I'll just make it a tabular form here. Chandrayaan 1 and Chandrayaan 2. Let's discuss about Chandrayaan 1 and Chandrayaan 2. Right? Now Chandrayaan 1 here, it was launched in October 2008. In 2008, right, by PSLV, we use the PSLV here. By PSLV C11, we use the PSLV C11 which was an extra large version. And this orbiter reached moon in 2009. Right? Whereas Chandrayaan 2, it was launched in 2019 and reached the moon in 2019. Same year. By using, which rocket we used for Chandrayaan 2 mission? We used a heavier one, GSLV Mark III Mk3 M1. We gave the name M1 there, right? ये blue marker चाहिए था. GSLV Mark III Mk3 M1. Let me read out there the point what I have given here, that Chandrayaan 1, it was first point launched in 2008 by PSLV C11. It was first extra large version of PSLV, and it reached the moon in 2009. Whereas the Chandrayaan 2 launched in 2019 and reached the moon in the same year, in the 2019, by using GSLV Mark III M1. Right? Now what comes the next point here is that Chandrayaan 2 mission, Chandrayaan 1 mission, what was the objective of Chandrayaan 1 mission? Chandrayaan 1 mission was a only orbiter. It was orbiter mission only. It was only an orbiter, just like a satellite going around the moon at a distance of 100 kilometers from the moon surface. Whereas Chandrayaan 2 has got two modules. It carried the two modules. The first one was orbiter, which is still working on the moon, still carrying out the function. And the second one is here, a lander, Vikram lander. It carried a Vikram lander. And within the lander, Pragyan rover. Right? Vikram lander and Pragyan rover. So it has a two module. One was the orbiter module. Second was the lander rover module. Right? Lander rover together, module was there. So it has a lander rover module there. Whereas here it was a orbiter module. Alright. Now coming to the third point here. Chandrayaan-1 mission, India's first lunar mission, had it carried 11 instruments, right, from India and other countries. There were US also, American and other countries, like they also, instruments were carried on board Chandrayaan-1, whereas Chandrayaan-2 is a completely indigenous. All instruments from India on board the orbiter and the part of it. Now, what was the fourth part, the mission objective? Chandrayaan-1 mission, the objective was to study surface of the moon, mineral studies, minerals, right? That was the part of the study of the surface of the moon, mineral mapping, right? Then presence of water. And since Chandrayaan-1 mission didn't last for a complete mission life, because of some problem with the thermal system of the Chandrayaan-1 orbiter, we have to end this mission. But Chandrayaan-1 mission has found loss of water from the moon surface. There was one instrument on the Chandrayaan-1 called as a MIP, Moon Impact Probe. And that Moon Impact Probe was crash landed on the moon. It was dropped on the moon. It carried the Tiranga, it carried the tricolor flag on the Moon Impact Probe, MIP, Moon Impact Probe. It was dropped to the moon surface. So when it was going down, it was able to detect loss of water from the moon, which NASA is still to confirm that. That's again another part. Whereas for Chandrayaan-2, what was the mission objective? Dark side of the moon, right? To study the south pole, or study the dark side of the moon, right? The dark side of the moon, where the Vikram lander with the Pragyan rover has to be dropped. But then unfortunately we lost the lander and the rover there. To study the dark side of the moon, which may have some important minerals, then water resources, water may be found there. Then about the minerals of the mineral mapping of the mineral study, surface feature of moon, right? Then finding water. All these are part of the Chandrayaan-2 mission there, right? So still the lunar orbiter of Chandrayaan-2 is working there. Right? Now what I'm coming here, Mangalyaan. Mars orbiter mission, Mangalyaan. I have already mentioned that how we were able to take this spacecraft to the Mars planet, right? We have already discussed that in the classroom there. That we use the transfer orbit concept and then slowly we raise the orbit and then take it to the Mars there, right? Now Mars orbiter mission, if you see the objective, the main objective of Mars orbit, so it was launched in 2013 by PSLV. Again, it was an extra large version, PSLV C-25, an extra large variant of the part of it, and it reached on 24 September 2014 and reached Mars, the red planet, in 2014, right? Now India becomes the first country in the world to have successfully taken the spacecraft in the first attempt. I am using the word first attempt. Successfully inserted in Mars orbit in the very first attempt, whereas NASA failed in the first attempt, Russia failed in the first attempt, European Space Agency failed in the first attempt, but India was able to do that, right? It is very low cost, affordable, small budget project was there. Now its objective. Objectives of Mangalyaan, it had two objectives, technological and scientific. So technological objective was, can India build a interplanetary kind of a mission spacecraft? Can India send it to the red planet, another planet, right? Can we communicate with the spacecraft from such long distance? These are the technological objectives and the challenges. At the same time, scientific objective is the study of red planet. So here we can divide into two broad categories. One is a technological objective. So what are technological objectives? Technological objective here is that, here is in terms of building the spacecraft, making such kind of a spacecraft, right? Then again, sending to the red planet, sending and inserting. That is again technological objective is inserting in orbit, and then again deep communication, deep space communication, to get all the data from the Mangalyaan to India. Right? That is called as the technological objective of the mission was there. So you know that it is India's first interplanetary mission. This is India's first interplanetary mission there, right? India's first interplanetary mission is there, right? India's first interplanetary mission, I'll write here. India's first interplanetary mission, Earth and the Mars, right? Now what are the scientific objectives of this mission? Now scientific objectives, now let us understand here the scientific objectives of the mission. The scientific objectives of the mission is that it carried, the first thing is that it carried 5 instruments. Mangalyaan has 5 instruments as a payload, and let me provide here. The first one is called here, that is called Mars sensor for methane, to find out the methane gas on Mars planet, which can indicate the presence of life. So to find out the methane, right, which can indicate the presence of life, right? The Mars sensor for methane. Then there is a Mars color camera to study the surface feature and all. There is a Mars color camera on board the Mangalyaan, right? Then comes here in terms of a very important name here called as the Mars exoatmospheric neutral composition analyzer. This is called MINCA. It stands for MINCA. Mars exoatmospheric neutral composition analyzer, which is for analyzing the atmospheric content or gases of the Mars planet. Then comes here, this is also called MINCA. Then you have another very important device here, Lyman alpha photometer, what is called LAP. Right, LAP. Now Lyman, Balmer, Paston, Pfund, these are the lines in the hydrogen spectrum. Through Lyman alpha photometer, it is trying to find out the spectrum in the hydrogen lines that may indirectly indicate the presence of water on red planet. So that is for looking for water there. And then there is a thermal, right, infrared, in terms of high temperature infrared spectrometer. There is a spectrometer to study the thermal event on the Mars planet. Clear, there are 5 instruments, one for the methane, then you have a color camera, just like remote sensing satellite, Earth observation, you have a color camera for mapping of the moon, surface of the Mars planet. Then Mars exoatmospheric neutral composition analyzer, study of the gases of the Martian atmosphere. Then Lyman alpha photometer, look out for water on Mars planet. And thermal infrared spectrometer, in terms of high energy event, thermal event on the Mars there, right? Now what I'm coming, third one, Aditya L1 mission. right? I have already given you that L1 point 1.5 kilometer, million kilometers, that is 15 lakh kilometers, halo orbit. So here, what is the first thing here? Halo orbit. It will place in halo orbit around Lagrange point L1 point at a distance of 15 lakh kilometers, right, between Earth and the Moon. Sorry, Earth and Sun, between Earth and Sun. Now what are the here? 400 kilogram spacecraft, satellite with 6 instrument as a payload. Now we have increased the instrument, now is 7 of them are there, right, with 7 instruments as payload is there. But let me put a 6 only there. Right, now I just confirm with that 6 or 7, though Rajya Sabha TV talked about 6 of them, right? But if you go to the actual ISRO site, let's say Aditya L1, so you have the names of the instrument also given there. See, names of the instruments are not very important. You don't have to memorize the names of the instrument because UPSC is not going to ask you the names of the instrument. Say 3, 4, 3, 3, 6. The 6 instruments are there. This is which are 6, 1, 2, 3. No, 7 are there. I am right. 7 instrument. Now it has been revised there. 7 instrument. Right? That is said that earlier it was 6. But now there is a 7 instrument there. Now it has been revised to 7 instruments. Right? Rajya Sabha TV, this documentary which I played said 6 of them, but now it has been revised to 7. Which are the 7 instruments? The total 7 instrument is this one: Visible Emission Line Coronagraph (VLC), then Solar Ultraviolet Imaging Telescope, then you have Aditya Solar Wind Particle Experiment, Plasma Analyzer Package for Aditya, Solar Low Energy X-ray Spectrometer, High Energy L1 Orbiting X-ray Spectrometer, then you have magnetometer there. Right? So there is Aditya mission has got. Now what is the objective here? The objectives of the Aditya mission is that, first is that to study outer corona of the sun, outer corona of the sun and coronal mass ejection. I have already mentioned in the classroom what is coronal mass ejection. Solar tsunami, solar storm, that which is emitted from the corona, that is called CME, coronal mass ejection, right? Powerful solar waves, flares with the particles they are emitted from such kind of a sun's corona there, what is called CME here. So that is a friend. Then second is that I have also discussed in the classroom to study the temperature difference. Why the outer corona of the sun has very high temperature, millions of degree Kelvin, whereas the inner photosphere has the 6000 Kelvin. It has to be other way around. Outer should be cooler, inner should be hot. But in the case of sun, it is just the opposite. Inner is the cooler than outer part. To study temperature difference, between outer corona, that is the millions of Kelvin, there is millions of degree Kelvin is there, and inner photo disk there, photo disk which has a 6000 Kelvin. So what is that reason that inside is the 6000 Kelvin and outside is the part of the 4000 millions of degree Kelvin outside temperature is there? Those event has to be studied. Now third point is that here what is very important, third objective of Aditya mission is that the effect of coronal mass ejection, that is the solar flares, CME, coronal mass ejection, that is called as the solar flares on space weather, on space weather. What is the effect of there? Space weather, right? That is another part comes into that one. So these are the three important one, and then now fourth one is the Astrosat. Right? Now Astrosat, it was launched in 2015 by PSLV C-30, right, into 650 kilometer orbit, low Earth orbit. The size of the satellite is 1515 kilograms, 1515 kilogram into 650 kilometer low Earth orbit. PSLV C-30 was used. Now it is a multi-wavelength. It is a multi-wavelength astronomical satellite of India. So it studies the universe in UV rays, visible light, and X-rays. Right? It has got 5 instrument as a payload, which has been developed by TIFR, which comes under Department of Atomic Energy. And the last point what comes here, that is the objective. So what are objective of Astrosat? 5 years time mission life the Astrosat was developed. So it is also called mini Hubble, right? Mini Hubble of India. And India is not the only country. Apart from India, US, Russia, then Japan, European country, they have also developed such astronomical satellite. Now objective is that first one, to study binary star system, to study neutron star and black hole, binary system of black hole and neutron star, to study high energy event, let's say supernova. What is supernova? Where the star dies with the burst, it explodes, and then lead to the death of the star. Study high energy events in the solar system. Then in terms of deep space survey, using the X-ray, let's say X-ray and all this can find such kind of a part of. So it then study about the birth region of star, like nebula and all this, study of birth region of stars. So that is a nebula where the stars are formed there, right? So what I have given objective to study neutron binary star system consisting of neutron star and black hole, to study high energy events like supernova and all this, to carry out deep space survey using X-rays, then study of birth region of stars, right? Birth region of stars there, like nebulas and all this one. Right? So these are the entire 4 space missions in terms of the astronomical study. Right? Clear here? So I have given you all the class notes. I have been telling you always in the classroom that whatever I am writing on the whiteboard, please write it down. I had given you a handout also. Right? Rishabh is asking that we found that after India had done with its Mars mission, it seems like there is a race between the countries to reach on Mars. Like recently UAE. Yes, very right. You are very, very right. Recently UAE, United Arab Emirates, US, China has done their mission. So why Mars have such importance in geopolitical world? Is it only because of the presence of life or any other things there? See, not only in terms of presence of life or something to find out in red planet, but the thing is that the red planet has certain important minerals also, which is found on the red planet. Red color of the Mars is because of the presence of the iron and all in large quantity. But this geopolitical situation in terms of UAE and the US and China, India, they just want to prove their supremacy. They can do it. They can, like, if India can do it, then why China will be banned? When China does it, then India also perform it. That if our neighbor does, then China carries out anything. India will not remain silent. India also want to do it, right? America is, right, USA right from beginning has been the pioneer in the field of astronomy and has been sending such spacecrafts to various parts of solar system and the study of solar system. UAE is the new player. You can say that United Arab Emirates and the Mars planet is a new player there. That is in terms of, maintaining a relationship with and getting into the space, right? UAE, they also want to have a, well-developed space program, right? And they are looking for market, what is something called space market. Right? India is having just 2% of the space market. That situation can be the part of, right? Right. So space market and part of getting the access to the space market. UAE has a lots of money. They are wealthy country. They are very rich country, and they want to have presence in the space market. So they are now developing the satellite with other countries like UAE, part of it, and UAE has done that. What, right? China India comes because of that neighborhood kind of relationship. We want to develop there. They also want to develop, right? USA has been doing for a long time there. All right, clear there. And another thing, who knows, maybe a long time, 20 years, 30 years, 50 years, there's already a mission, right, underway where international mission, not national mission, international mission to land a man on the Mars. If you have seen a movie Martian, right, landing man on the Mars, inhabiting Mars, right. So who knows, maybe 50 years, 100 years, it will be a reality, man coming to the Mars, going to the Mars, right? That can be the. Anyway, we'll complete here space science and technology, and we will have the next class. Tomorrow is the next class. We'll study nuclear science and technology. That's what I have not started nuclear technology in today's class. We will be studying nuclear technology in the next class. Tomorrow we'll be starting the nuclear science and technology. All right. And I'm giving you the assignment question here. The assignment question is this one. Your today's assignment question is that discuss important space exploration missions of India. Your homework assignment is that discuss important space exploration missions of India. Mention their significance for the country. What is the significance of such space missions to explore the solar system or astronomical aspect for the country, right? So here, answer in 150 words. 150 to 200 words, 10 marks question. Discuss important space exploration missions of India, then mention their significance for the country. Answer 150 to 200 words. So Deepak is asking question, is there still a possibility for ISRO to establish a connection with Chandrayaan 2? Very grim, very low chance. We have located where the Vikram lander is there, right? We have found out where the Vikram lander has crash landed. We have identified the spot. Is again Uparwala. Is something chamatkar. If miracle happens, and then if some component of the Vikram lander or Pragyan rover still works and sends signal, and the signal can be established with the orbiter. The orbiter which goes around the moon is able to establish a signal with the part of the components of the Vikram lander and the Pragyan rover. Then we can initiate. If the Vikram lander and the Pragyan rover and its components have been damaged, if they are damaged, then there is a very grim chance that we will be able to establish the signal. But ISRO is trying there. ISRO still start trying with that. All right. So thank you everyone. We will start the nuclear science and technology next class there. Right. I have discussed every aspect of the science, space technology. We will be going to the nuclear technology. Thank you everyone. Thank you.